Yes, good evening, guys, to all of you. I welcome you all on this wonderful platform that is BYJU'S exam prep. So, guys, please tell me, am I properly audible and visible to all of you or not? Then we are starting the session, guys. So, if we are talking about today's session, that is related to theory of machines, and in today's session, we are going to talk about a very important thing, that is crank and slotted lever mechanism. So please tell me, guys, am I properly audible and visible? Let me check. Yes, I feel everything is fine. Fine. So guys, now we are starting the session. So today's discussion will be crank and slotted lever mechanism. So guys, if you are talking about the machines like shaper, if we are talking about the machines like planer, then my dear, shaper and planer both are working on this mechanism, that is crank and slotted lever mechanism. And when we are talking about shaper and planer, they are coming under the production part. So theory of machines have this work actually to make the mechanisms, to make the machines, to make the mechanism for the machines of production, for the machine of manufacturing sizes. So that is basically the task of these mechanism, or you can say theory of machines. So guys, this is some detail about me. I'm having around 10 plus years of experience, and this subject is theory of machines. And I already told you that the very first chapter of theory of machines is simple mechanism. And from this simple mechanism, every year question is coming, and question comes from three areas. One is degree of freedom, other is you can say Grashof law, and the third one is going to be the crank and slotted lever mechanism. Okay, so in this startup series right now, our target is to cover these 2 marks. So that is why we are covering these 3 topics, or you can say these topics in this series for this week. So guys, one very important announcement related to a workshop. Generally we are interested to listen from the toppers. So guys, here on 7th of May, 12:30 p.m, you are having a free workshop on how to ace GATE in first attempt, and that will be insight from the GATE AIR 12. The name of the student who will be taking this is Rashul Chutani, and he will be taking this workshop. So guys, you would be learning from his experiences, and that also you can apply onto yours journey. So we are starting the session, guys. Please tell me, am I properly audible and visible to all or not? And if you want to register for the workshop for the free, then my dear, you can go to the this description box. Their link of the workshop will be there. Yes. Fine. So guys, let's start the session. Now, my dear, we are talking about the single slider crank mechanism. If you remember, in the last class, we have talked about the simple 4-bar mechanism. And when we talked about the simple 4-bar mechanism, there the number of links were 4, 1, 2, 3 and 4. 4 number of links. And if you remember, when we say the 4 number of links, we also said that 1, 2, 3 and 4, these are 4 turning pairs. So the number of turning pairs we said were 4. So 4 links, 4 turning pair were there, and this was the very first, you can say, first type of simple 4-bar mechanism. And then if you are going to change these number of turning pair, you can get some other configuration of 4-bar mechanism as well. Like, my dear, if you are going for like 3 turning pair and 1 sliding pair, then you will be getting one more kind of configuration of simple 4-bar mechanism, and that looks like this. This is said to be single slider crank mechanism. Here, if you will check, this fixed link is link number 1. Then we are having this crank. Why crank? Because it is having the complete rotation. In the last class, we discussed about that. This is our link number 2. Then we have a connecting rod, our link number 3. Then we have a piston, link number 4. Then we have the cylinder, which is once again fixed. Fixed means it will be having the same number. I told you the 2 links which do not have any relative motion will be considered to be the same. So link number 1, this cylinder and this will be same because they don't have any relative motion. Okay. So that is why they are considered to be the same. So guys, this is you can say configuration of 4-bar mechanism, in which one turning pair is converted by a sliding pair. Okay, that is the discussion. So guys, now we are moving further. So if you're talking about this, if someone asks you how many number of links, you will say 4. How many turning pair, you will say 3. How many sliding pair, you will say 1. So my dear, if I ask you how many inversions are possible, then you will say the maximum possible inversions would be 4, because maximum number of inversion can be equals to the number of links. But if any of the link is going to give the same kind of relative motion, then we will be calling it as the same inversion. So maximum possible inversions can be 4, but it is not guaranteed that 4 will be there. It can be less than 4 as well, as in simple 4-bar mechanism we had 3 inversions. Guys, please tell me, am I properly audible, visible to all of you? I am unable to see whether. Okay, fine guys, moving further. So guys, now we are talking about the inversions. When we are going to fix the cylinder, then we will be getting the first inversion. And when we are talking about the first inversion, when cylinder is kept fixed, we will be getting two mechanisms. One is we will be getting the reciprocating IC engine, and other we will be getting the reciprocating compressor. Okay, so guys, reciprocating IC engine and reciprocating compressor. Yes, Shivam, fine, thanks for the message. So guys, when we are talking about this reciprocating IC engine and reciprocating compressor, both would be considered as the same inversion because they both have the same relative motion. Only the difference is when I am saying that it is an IC engine, then the point is, you know that in IC engine, power stroke is something responsible for the mechanism. So you will say input will be on the slider. Input will be on the slider and output will be on the crank. Then we will call it as reciprocating IC engine. But if input will be on the crank and output will be on the slider, we will call it as reciprocating compressor. So whether you are going to call it as reciprocating IC engine or reciprocating compressor, it will totally be depending upon where it is input, where is the output, but they both are coming under the first inversion. They are not the different inversions. They are same because the relative motion is here reciprocation, here rotation. Until and unless relative motion will remain the same, the inversion will remain the same. So guys, next we are talking about the second inversion. Second inversion we will get when the second link is going to be fixed, that is crank. So when you are going to fix the crank, you will get Whitworth quick return motion mechanism and rotary IC engine. Okay, so Whitworth quick return motion mechanism was the very first mechanism which was given the name of quick return motion mechanism, and this was the very first mechanism on which shaper and planer were made. You may be saying, sir, you are just contradicting your statement. In the starting you said ki crank and slotted lever mechanism is the mechanism on which shaper and planer are working. And now you said the very first shaper and planer was made on the Whitworth. So I said the very first was made on the Whitworth. After that, a lot of improvements were done. So because of those improvements, my dear, nowadays all shaper and planer are made on crank and slotted lever mechanism. Is it clear for everyone? So guys, please tell me, are you getting or not? Okay. Yes. Okay, I am just sharing it so that other student, those who didn't get the message of starting of class, because generally the time of class is 11 p.m. Today I am taking it at some 6 p.m. time. So maybe some students would not be aware. So I am sharing it again. Okay, fine guys. So moving further now. Then my dear, we are talking about the third inversion when you will be keeping the connecting rod fixed. Mind it, at one time only one link will be kept fixed. If I am fixing the connecting rod, then other links will be free. So when you will fix the connecting rod, you will get crank and slotted lever mechanism, which is today's discussion is depending on. So today's discussion will be on this. Today's discussion. Okay. Then my dear, oscillating cylinder engine is the second possibility. I am also telling you here, we are going to have input rotation, output rotation. In the previous one, we were having rotation to reciprocation. One will be input, other will be output. Here you can say one will be input, other will be output. Then we are going to have here, that is reciprocating. Sorry, here we will be having what? Here we will be having rotation to oscillation. So I feel you know the difference between oscillation and reciprocation. So it is rotation to oscillation. One will be input, other will be output. Okay. Then moving to the last inversion, when you will be keeping the slider to be fixed, piston to be fixed, you will get head pump. And here the motion will be oscillation and sliding. So you can see in all the four inversion, we are getting different types of relative motion. And I would also like to tell you guys, when we are talking about these inversions, like simple 4-bar mechanism gives us 3 inversions. We have seen that. This mechanism gives 4 inversions. We have seen that. And the next mechanism, that is double slider crank mechanism, that will give 3 inversions, that we will see tomorrow at the same time. Okay. So now we are moving to the main discussion, where our question will be framing and what is mentioned as today's thumbnail. So today's session is going to be on crank and slotted lever quick return motion mechanism. First we need to learn what is quick return motion mechanism meaning. Okay. So to understand the meaning of this mechanism, I am showing you something. Okay. So for that, what I am showing you is just look at it. Let me just lock this phone. Now my dear, you can see this is nothing but our plate, and I want to do machining on that. This is my cutting tool. So in shaper and planer, what is going to happen? This tool will be passing through this workpiece and machining will happen, and it will be coming back idle. Idle means during forward stroke cutting will happen, during return stroke cutting will not happen. So in forward stroke cutting is happening, something is going on, return nothing is happening. So the point is return strokes are said to be idle. What word I am using? I am using the word idle. Idle means when work is not going to be done. So my dear, forward stroke is going to be working, return stroke is going to be idle. So it means we want return to be lesser time taking. Why? Because return is wastage of time. In forward work is done, no issues. काम हो रहा है, उसमें समय लगे कोई प्रॉब्लम नहीं है, पर कुछ काम ही नहीं हो रहा. If you are studying, sitting for 6 hours and you are studying, that's fine. Those 6 hours are utilized. But if you are sitting, nothing doing, this is idle. And we want to reduce that time always. That is the time which is going to be wasted. So to reduce that, my dear, we wanted the return to be faster. So we want forward should go slowly, 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 slowly. Return should come fast. Forward should go slowly, slowly, slowly. Return should be fast. So that kind of mechanism where return stroke is going to be faster, we call such mechanisms as quick return motion mechanism. In short form, we are calling them as QRMM. And when we are talking about, this is not the first QRMM. First was Whitworth. This is the QRMM which is nowadays used. And my dear, when you are going to see how it is QRMM, what is the concept or size behind that, let us discuss that. So first try to understand this mechanism. In this mechanism, you are going to have this link. This is a link which is going to rotate in this circle. Okay. And my dear, I would also like to tell you, when this link is going to rotate in this circle, we have kept a slider over this link. So when we are keeping slider over this link, this slider will be rotating in this circle. Okay. And why it will be rotating? Because we are going to provide a motor here. That motor will rotate the link, because of which this link will be rotating in the circle. This slider will rotate in the circle. That's fine. Now what we have done, we are using a slotted bar. This is said to be a slotted bar. This is a bar in which slots would be there. And this slider is coming inside this slotted bar. So when this slider will be rotating in this circle, what is going to happen? Let us try to see. Let us say slider is moving from this position to this position. From B1 to B2 slider is moving. And when this is moving like this, obviously when slider will try to move, this crank will be giving a velocity like this. And this velocity will be perpendicular to the crank. But you know, this velocity will be having two components. One component will be perpendicular to slotted bar. Other component will be parallel to slotted bar. So the component which is parallel to slotted bar, because of that the slider will be sliding in this slotted bar, and the second component will try to give the motion to the slotted bar. So my dear, when this is going from B1 to B2, then my dear, this is going from C1 to C2. It means the forward stroke will happen. So you can say when you are going for beta angle, you are going to complete the forward stroke. So beta angle is related to the forward stroke. Now my dear, when you are going from B2 to B1, you are going to go for an angle of alpha, and this time the slotted bar will be going from C2 to C1. So I can say alpha is the angle which is related to the return stroke. So when that is the case, anyone can say beta is more than alpha. So the mechanism is made in such a way that beta will be more than alpha. What is the benefit of that? My dear, motor is rotating with a constant speed. Omega is given as theta by time. So if you are going to increase the angle, the time will automatically increase. So my dear, when you are going to increase the angle rotated by the crank in the forward stroke, automatically the time required for forward stroke will also increase. And my dear, because the ratio is going to be constant. So as you are saying beta is going to be more than alpha, we must say time required for forward stroke should be more than time required for the return stroke. And that is how forward stroke will be taking more time, return stroke will be taking lesser time. So we can say this mechanism is a quick return motion mechanism. So return would be getting quick. So when this alpha angle will be rotated in that much time, it has to come back. And then you are extending it to the tool, and this tool will be reciprocating R1 to R2, R2 to R1. So forward stroke will be slower and return stroke will be faster. This is how the mechanism is working, and this is how the machine will be copying this mechanism. So we discussed the basic and the science behind that. What is the science? Increase the angle, time will increase. Reduce the angle, time will reduce. And this ratio beta by alpha, which is also written as time required for forward to time required to return stroke, this is said to be quick return ratio. And I would like to tell you, if this is quick return ratio, then my dear, this ratio of TF and TR, this ratio of beta and alpha, it is always going to be more than 1. If in any of the question examiner gives this lesser than 1, it means he have given it just to confuse you. You will take the inverse of that value. Like if he gives the value as half, you will take it 2, because quick return ratio can never be less than 1. If he is giving less than 1, it means he is giving you alpha by beta. But always remember, beta is always more than alpha, QRR is always more than 1. Then only we call it as quick return motion mechanism. Is it clear guys for everyone? Are everybody getting or not? Please tell me that. I am trying कि आप सभी लोग समझ पाए चीजों को. If still any doubt, do ask in the comment section. We will discuss questions as well, and we will derive the relation as well. So my dear, this is the animation of this mechanism. You can feel that how forward is taking time and return is going fastly. You can feel it. Forward is coming slowly, slowly, slowly. Return is going like that. So that is the beautiful mechanism. Is it clear? So we are sharing you animations as well. We are sharing you derivation as well. We are trying to give you the complete package. Questions are also going to be discussed. So guys, now we are moving for the derivation part. So this was the mechanism we have already discussed. Now my dear, I want to find out the stroke length. So when RAM is traveling from R1 to R2, this is our stroke length. So if you ask me, sir, what is the stroke length? Then my dear, I will say stroke length is R1, R2. But my dear, the same R1, R2 can be written as C1, C2, as they are parallel to each other. So we can write it as C1, C2 as well. Now my dear, we have kept a perpendicular from A to M, which is dividing C1, C2 because of symmetry equally. So we can also say it can be written as 2 times C1M. Now my dear, if you want this C1M, then my dear, you can feel there is a triangle. This is the triangle. I feel you can see this triangle. And if we are talking about this triangle, up to this, whatever the distance is, we call it as length of connecting rod. That is the fixed link. And after that, when we are talking about, if this is the L, and this length is nothing but the length of slotted bar, we are denoting it by LS. And crank length, we are showing it as R. Okay, that is the case. You can see if this total angle is alpha, this half angle will be alpha by 2. And if this angle is alpha by 2, this angle is 90, then this angle must be 90 minus alpha by 2. Okay, so this angle is 90 minus alpha by 2. If this is 90 minus alpha by 2, this is 90, this is going to be alpha by 2. So my dear, if that is the case, you can use the cos alpha by 2 for this triangle. triangle A, C1M, we can write cos alpha by 2 as. So when we are talking about this cos alpha by 2 for this triangle, then my dear, you know it is going to be base upon hypotenuse. So if this is the angle alpha by 2, this is going to be base, this is going to be base, or this is going to be base. Yes, this is 90 degree. So this is going to be perpendicular. So you will be getting from this as C1M is equals to AC1 cos alpha by 2. So it means this is C1M by AC1. So you got the value of C1M. You can write C1 C2 R1 R2 as equals to C1 C2. That is 2 C1M. That is 2 AC1 cos alpha by 2. Now my dear, the time is to put the value of cos alpha by 2. When we are going to see this triangle, this small triangle, just try to see this triangle. You already know this value is R, this value is L, and this angle is alpha by 2. And if this angle is alpha by 2, from this triangle you can write cos alpha by 2 is equals to, this is O dash. You can write O dash B1 by O dash A, which is R by L. So the stroke length value, which is C1 C2 R1 R2, will be coming out to be 2 times AC1, and cos alpha by 2 is O dash B1 by O dash A. Putting the value, you will get 2 into LS into R by L. This is the formula derived from the stroke length. If you are preparing only for gate and ESE objective, gate is objective only. For gate only if you are preparing, then this derivation is not required, results are enough. So you can say till now there is no question on this. Okay, so stroke length generally they are asking about the quick return ratio. Okay, and that I already told you, but still question can come on this in an objective format. So for that they will give you the length of slotted bar, they will give you the radius of crank, they will give you the length of connecting rod. Putting these values, you can definitely find out the value of stroke length. So my dear, this is how the stroke length can be calculated. So guys, do like the session, share the session, and also subscribe the channel if you have not done yet. The reason is because, as I already said, that when we are talking about these sessions, they are going to improve your marks, because we are going to talk about the topic which are shortcoming in the paper. Okay, so just like, share and subscribe. So guys, this will give you the stroke length value. And now my dear, sometime they are also asking the area swept by slotted bar. What is that? Let us discuss. Like slotted bar is moving from this to this, so it is going to swap some area. Sometimes they are asking about this area. Okay, so if they ask, you can say that this area they are asking, it can be considered as a part of a circle whose radius is LS. So you can say, if we want to write down this area, you know this angle we must know. If this angle is gamma, then we can write total area of circle is pi LS ka square. This is the total area of circle, and that is coming for 360 degrees. Then you can say for 1 degree it is pi LS square divided by 360, and we want it for gamma degree. So for gamma degree, the area swept will be coming out to be pi LS ka square into gamma by 360. So this is how the things will be coming. If you are going to put the values in the degrees, if you will put in radian, then you will put it 2 pi. So these are the results which are important from this topic. I derived it in front of you. I explained you with the animation, but as a result, what you need to remember, only these two formula for gate and ESE objective. For ESE, conventional derivation is also important. So I have done both. So I am taking care of gate, ESE, all the exams. Even for BARC examination, ISRO examination, it is equally important. So we are taking those most important topics in the series. So guys, now we will also see some of the questions as we have done the formulas. I am writing the formula. Quick return ratio is beta by alpha. Okay. TF by TR. We know the cos alpha by 2 is R by L. We know the stroke length is 2 times LS R by L. And we know the area swept by slotted bar as this is pi ls ka square into gamma by 360. Fine. If you are talking about gamma, I can give you much clear picture. As this was gamma, this will be gamma by 2. And if this is gamma by 2, this is alpha by 2, and this is 90. Then gamma by 2 is nothing but 90 minus alpha by 2. And gamma can be written as 180 minus alpha. So you can further rewrite it as pi ls ka square 180 minus alpha by 360. Things are going to be on much easier way. Okay. So I told you all the formulas. Now my dear, when you are saying that prepare the short notes, these are short notes. When you are making the short notes, what you will be doing? You will be just making this mechanism and you will be writing these formula. This is short notes. Okay. And when we are going to explain it completely, deriving the things, they are class notes. So if you don't want to make short notes, then it's also okay, because they are the part of class notes. Okay. Moving to the very first question, guys. So I told you we will see the question from last class, Grashof law, and also from today's class, crank and slow lever mechanism. This question is from Grashof law from the last class. Shivam, sir, is derivation also important for SSC JEE mains? Dear, yes. For SSC JEE mains, derivations are very important. I remember many times I have seen the paper. At that time, even auto cycle efficiency, diesel cycle efficiency, those kind of derivations are coming. So yes, definitely they are very important. Okay. Even those are more important than numericals. So now we are moving to the very first question. A 4-bar mechanism with all revolute pairs and link lengths. They are saying fixed link is 30 mm. Input is 40 mm. Coupler is 50 mm. Output is 70 mm. By looking into that, you can say that the fixed link is the shortest one, 30 mm. Okay, and the output link is the longest one. Output link is the longest one, 700 mm. Other two links, P and Q, they are 40 mm and 50 mm. If you will see, you can write S plus L is, this is 30 and 70. Okay, 30 and 70 is 100. And if you see P plus Q, it is going to be 90 mm. So they are asking us, both links can execute full circular motion. Both link cannot execute full circular motion. Only the output link cannot execute full circular motion, and only the input link cannot execute full circular motion. If you see, shortest link is 30 mm, longest link is 70 mm. So 30 plus 70 is 100, 40 plus 50 is 90. So here if you see, S plus L is more than P plus Q. If law would be satisfied, then it would be double crank mechanism. But if law is not satisfied, it would be double rocker mechanism. Why? Because if law is satisfied, then we will check the fixed link, and fixed link here is the shortest link. So based on that, we can say the answer should be the double crank mechanism. Based on that, the answer should be 1. But as we can see, law is not satisfied, the answer will be B, because it is going to be double rocker mechanism. So that is the point I want to tell you. Before we go into this, first of all, we need to check whether the law is satisfied or not. Because if law is not satisfied, no need to check which one is fixed. That is the wonderful thing about that kind of question. Although whatever the question till date asked, they were asking about the questions where already everything is satisfied, then the answer will be very easy to calculate. Okay. So first of all, always check whether Grashof law is valid or not. Moving to the next question. In a 4-bar mechanism, length of input, output, rocker and fixed links are 4, 5, 6 and 8. So you can see shortest is 4, longest is 8, sum is 12, P is 5, Q is 6, the sum is 11. Without thinking, you will say double rocker mechanism. Okay, that is the type of question comes in engineering services. Okay, this is PYQ of gate. Obviously, Grashof law is S plus L is less than equals to P plus Q. Okay, because they are asking about that only. Grashof law says that you will get at least one crank if this statement is satisfied. Okay, so I wanted to show how the questions are framed. This is the best question from Grashof law in GATE. This is the PYQ of GATE. This is the best question from this topic. Okay, if you see this topic, a PQRS planar closed kinematic chain is formed with rigid links. We will say PQ to be 2 meters, QR to be 3 meters, RS to be 2.5 meters, SP will be 2.7 meters. So if you see, this is going to be the shortest link, going to be the longest link. S plus L is 2 plus 3, 5. P plus Q, 2.5 plus 2.7. It is 5.2. So S plus L less than P plus Q. Law satisfied. Law satisfied. Now you need to check which mechanism they are talking about. They are asking us for rocker mechanism, double rocker. But law is satisfied? Law satisfied. If law is satisfied, then you will get double rocker only in one condition, if shortest link becomes coupler. So you arbitrarily make a 4-bar mechanism. You are saying shortest should be coupler. And coupler ke samne, in front of coupler, we are having the fixed link. So they are already saying PQ is the shortest link. You will give the name PQ. Then you know QR. Then you know RS and SP. So obviously RS should be the fixed link for that. C is the answer. This is how beautifully we can answer. These are the questions from the Grashof law. So what we are doing is what we discussed in the last class. We are taking the question here so that with the revision when you are coming, it is easier for you to answer the questions. Okay. Now my dear, this is one more question. They are saying there are 4 links, P, Q, R, S, P less than Q less than R less than S. Which of these links should be fixed one obtaining double crank mechanism? So to get double crank, they are already saying law is satisfied and obviously shortest link should be fixed. So answer will be link of length P. Okay guys, link of length P. Now my dear, one more question. Okay. So today we are taking the question on the Grashof law. Tomorrow we will take the question on the crank and slotted lever mechanism, because today we have discussed, you revise it. Tomorrow we will see the question on that. Now he is saying for this. Yes, Shivam, are you getting it? Everyone, please tell that. This is the last question for today's session. Then we will close the session. A 4-bar mechanism is shown in the figure. PQ, QR, RS and SP. This is 400 mm, 600 mm, 300 mm. They are saying that for the mechanism to be crank rocker, the length of the PQ should be, for the mechanism to be crank rocker, this will be crank rocker if this is the shortest link. Shortest means it should be either it should be shortest or this should be shortest. One out of these two should be shortest. Okay. But at the same time, law must be satisfied. So if you are going to have either this as shortest or this as shortest, then obviously one should be rotating. If both will be shortest, then it will be double crank. So you can also check the values. If you are going to give 300 mm, then you can say if this is going to be 300, shortest plus longest 900, this is 300 plus 700. So obviously here you will be having, this is shortest, this is longest, you will be having double rocker. If you are going to use the value 200 mm, then this is 200. 200 plus 600 is 800. 400 plus 300 is 700. Then it will be obviously 400 plus 300, 700, 800 is more. So you will be having double rocker. If you are using 350, if this is 350, then also the law is not satisfied. So only for 80 mm law will satisfy it, because 80 plus 600 is 680 and this is going to be 700. So for 80 law will be satisfied, because for double crank S plus L should be less than equals to P plus Q. Okay guys, so these are the questions we have done. Yes. Fine. So guys, today we are stopping the session here. Now we will be meeting tomorrow at the same time. Last session of startup theory of machines. Tomorrow we will see question on single slider and theory of double slider. Goodbye for this session. Thanks for joining. Good night.